Hi, and thanks for tuning in to the CBA Podcast, a place where we chat about our own recent achievements in the area of electronics, software and mechanical engineering, and more likely than not, give excuses for not having done anything at all. This exciting episode will be talking about avoiding or circumventing or ignoring or quick fixing a weird electrical problem, redesigning the baseboard for my CPU project, and making the enclosure for the same project. Hello and welcome back. It's been about 2.5 weeks since the last podcast. Now, I have an excuse for that. I have been sick for about a week, and I've been doing some non-tech hobby stuff, which is also very nice, but we will not be talking about that now. Last time I talked about a weird electrical problem where a chip, the 74LVC06, that is a open collector inverter, went into a mode where it pulled a lot of current. Every one out of so many times that you powered it on, it went into that mode, pulled a lot of current until it powered it down. Now, from what I read, that smells like latch up. It's typical symptoms of latch up. I don't know enough about what exactly goes on inside the IC to reason about that. So after some screwing around, I ended up simply swapping the 74LVC06 for 74LV06 just to try something out. And behold, everything worked. That is, out of 650 times I powered it on, it worked 650 times, so I'll call that fixed. Now, I don't know what the root cause was, and that's a little bit dangerous. I don't like that. There was an ex-colleague of mine who used to say, whatever you ignore will come back at some point to bug you later, at a more inconvenient moment. And I believe that's very true, because everything I've ignored here has come back to bug me at a more inconvenient moment later. So I'm sure this problem will come back at some point. So would be smart after the Maker Faire, because the whole thing, the whole effort is to get this ready for the Maker Faire in Dortmund, 10 and 11 March. After that, it would be a smart idea to investigate a little more, or ask help, or search help, or something like that, because I want to know what's going on. Faulty chip was sitting on the I/O module, on each I/O module, so when swapping the chip, the I/O modules are okay. So what I did was order the remaining I/O modules to be assembled. They will arrive later this week. They can be assembled in a day or something like that, and then they're done. I have to test them, and then they're ready. One other thing I did was redesign the baseboard for the CPU. The main differences compared to the previous version is that this is smaller, looks a bit nicer, it's a bit more rounded. The previous one was square. And the new one can run standalone, so instead of needing a laptop for emulated RAM and ROM, it can stand alone. It has its own RAM and ROM, and it's basically a small computer system now, with a lot of emulation going on, except the CPU is implemented in digital logic, using transistors. To do that, I use a lot of shift registers, like I mentioned last time. I use a 74166 parallel to serial shift registers, and 74595 serial to parallel shift registers. I also use the latter one to directly drive LEDs, because each LED takes about between 1 and 2 milliamps, so there's no problem for the chip. For RAM and ROM, I use a serial flash and serial RAM on board. Now, in case I run out of time or stuff doesn't work, I can always use the microcontroller's internal RAM and ROM as program and data storage area. So that will work fine. Program will be simpler, but whatever, it will work. As a microcontroller to interface between the RAM and ROM on one side and the electrical interface to the CPU on the CPU side, I use a Atmega 168, which is a nice 32-pin TQFP processor with 16K of flash, which should be plenty. I think 8K and maybe even 4K should be more than enough. For power to the board, I was planning on using a switch mode converter plus some intelligence. Now instead I took the lame approach, namely use an LDO and use 2 USB ports. One to be simply connected to a USB charger or something that can deliver, let's say, 300 milliamps to power the baseboard, and another one for communication. Now that's a pretty lame approach. Normally you would use one USB port and have it go into a power saving mode, where some subsystems of the device of the baseboard are disabled until the USB host can supply the full current that the baseboard needs. But that's a risk for error, plus it takes a little bit more thinking, a little bit more intelligence, a little bit more software, plus you have to ensure that the subsystems can be disabled properly. And instead of doing that, I just chose to always have one power entry connector, and I happen to choose a USB connector for that because that's the easiest. Everyone has a USB charger. A micro USB B is very common, so I'll do that. Right after submitting the layout files, I noticed a problem. It's not a big deal. The footprint for a switch was drawn a little bit differently than what it should have been. I was planning on doing that, but of course I forgot. It's no big deal. I can solder them on anyway. So that's a baseboard. Hopefully that works. It will arrive next week. I'll assemble it probably in a day or something like that, and test it the upcoming weekend, and then I have a week for panic and last minute changes and the enclosure. For the enclosure, I was planning on having something reasonably fancy. Instead, I'll settle on an enclosure made out of a single sheet of acrylic, bent into shape, like with the mesh structure that I talked about in a previous episode. Showed a picture of that as well. So I'll do that. That should be nice. So the enclosure forms the top of the whole CPU plus the front panel, where the LEDs, the 8x8 LED matrix is shown using also acrylic light pipes, and an overlay for buttons. So there's that. And using engraving, you can make nice stuff. You can make circles around buttons or letters or something like that, or places where LEDs shine through the acrylic. You can do nice effects with that. So yeah, that's basically it for the previous CPU baseboard. I used 2 external controllers to play a game for the Maker Faire. It's nice to have kids, for example kids or visitors, do something interactive with the thing. So what I did was make a game where you have 2 players and you can shoot an alien, something like that, like Space Invaders with 1 Space Invader. And I used two makeshift controllers connected with cables to the CPU for that. So each player could use a controller connected with a cable to the CPU. In this case, I'll have the control of fire buttons on the CPU, on the baseboard itself, so people would have to push buttons on the baseboard. So that saves a lot of hassle, right? And stuff doesn't break down, and it's much easier, and the standalone is just one thing. Kits can be a bit rough, so I'm not sure if that will survive 2 days, but we'll see how that goes. And that was basically all I did. Just now, one of the guys who made the Gigatron homebrew VGA TTL logic computer, which is basically a VGA capable homebrew computer made out of TTL logic gates, was here to drop off something. Very nice talk, very nice project, nice people. So I'll put a URL in the show notes again. Also, there is going to be a hackerspace in Eindhoven, or another one at least. That's Hackalot, hackalot.nl. By the way, the URL for the Gigatron is gigatron.io. I'll put that in show notes as well. They don't have an actual location yet. I think they have weekly or bi-weekly or something like that meetings to see where they can, what locations are available, or plans for the future or something like that. So it's a very preliminary stage, but maybe it would be good to attend such a meeting at some point. Coming 2 weeks, I don't have time for that, but after that, sure, why not? And also, there is a guy in Helmond, that's very close by. I am in Eindhoven, who is planning and actually working on starting a home computer museum, which should open in 17 March. That is homecomputermuseum.nl. Send an email if I could help with something. Yes, of course, it was appreciated. So I'm a little bit busy before the Maker Faire, but maybe before that, or at least after that, I can help for half a day or something like that. So see what that is and get acquainted, and yeah, why not? So that was basically all. So that was all for now. For more information, links and previous episodes, visit podcast.cba.si. Stay tuned, thanks for listening, and goodbye.